Brain-computer interfaces (BCIs) are cutting-edge systems that enable direct communication between the human brain and external devices, bypassing the need for traditional motor pathways like speech or movement. These interfaces work by detecting electrical signals from the brain, typically using electrodes placed on the scalp, non-invasive, or implanted directly into brain tissue, invasive, and translating those signals into digital commands. This technology has already allowed paralyzed individuals to move robotic arms, type on virtual keyboards, and even control wheelchairs with their thoughts. The most advanced BCIs, such as those developed by Neuralink, aim to go even further by enabling real-time, high-resolution two-way communication between the brain and machines. Researchers believe that in the near future, BCIs could help restore vision, improve memory, treat neurological disorders like Parkinson's and epilepsy, and possibly enhance human cognition beyond natural limits. However, the field also raises ethical questions around privacy, identity, and the potential misuse of neurodata. Despite these concerns, BCIs represent one of the most transformative frontiers in neuroscience and bioengineering, bringing us closer to a world where the boundaries between biology and technology begin to blur.